Welcome to the Chatelier Principle and temperature. We've done videos previously on the different factors that affect equilibrium, such as pressure, volume, and concentration, and now we're on to temperature. If we remember that the Chatelier Principle states that an equilibrium system can be disturbed, and if it is disturbed, it will move in a direction that will minimize that disturbance, okay? And a new equilibrium is established. So let's have a look. Well, here we have our good old dinitrogen tetroxide and nitrogen dioxide equilibrium. But what we're going to be doing here is we're going to be changing the temperature. Now this reaction is an endothermic reaction, and we can see that in the equation here because we've put heat in the reactant side. So it's endothermic. So for the reaction to happen, it needs to absorb heat from the surroundings so that the reactants have enough energy to produce the products. And so we would feel that as it being cold because it's absorbing energy from the surroundings into the system. So that's what an endothermic reaction is. Now, according to Le Chatelier's principle, if the temperature of the system at equilibrium is changed, the system will shift in the direction to counteract that change. So let's have a look at the scenario here. Let's start on the left-hand side, and we can see that we're going to remove heat. So if we remove heat from the reactant, then the reaction is going to shift from the brown nitrogen dioxide towards the left so that it can produce more heat, right? So we're removing heat, and the reaction moves in the direction to minimize that change, and that is the direction that is producing heat, right? So that means that what would you see macroscopically in the beaker? Well, you would see the intensity of the brown decrease because its concentration is getting lower and becoming colorless. And we can see that in the picture here, that when the vial is placed in a container with dry ice, it's cooling it down, which therefore removes heat. That causes the reaction to shift towards the left, and then we see a colorless gas inside there. What about if we do the reverse? Well, let's add heat, and see here they're placing the vial in hot water, so we're adding heat. That means that the system will want to move in the direction to minimize that change, that it's going to shift towards the right-hand side, and that means that it's going to produce more brown nitrogen dioxide. And that's what we see here. So that's an example of how temperature affects a reaction. And this is an endothermic reaction, but the same principle applies if you have an exothermic reaction. It's just that the heat is going to be on the product side. And if you add heat, right, with an exothermic reaction, it'll go in the direction to consume heat, which is towards the left, right? If you remove heat, it'll go in the direction to produce heat, which is towards the right. So temperature can affect an equilibrium position, and you need to look at delta H for that reaction to know whether it's endothermic or exothermic. Right, that's it for equilibrium with temperature change. Hope it makes sense, and keep watching these chemistry videos because it will sink in and you'll achieve great results. See you next time.